it's always so hard to find a you know, suitable spot to end that awesome groove. What is up with chat? Hold on. Why is the overlay not working? Chat. There we go. Okay, sorry about that. Had to fix chat. Chat is such an important part of these live streams, and it wasn't there, so had to go fix it real quick. Sorry about that. But yeah, fixed. Now, today, let's order pizza. It doesn't work. Nobody delivers pizza here. Thanks for the offer, though. It doesn't work. Today, we are going to take a second look at the CNC Mill 1. Yeah, see, again, I still can't get along with that name. The CNC, you get the joke probably. Last time we had a bit of a how do we call this, unpleasant experience, because like software and Java and like but I think I feel prepared. I feel like this is gonna be okay. Let's just see how it goes. If it doesn't go well, I might pull the recording of this stream off of the main channel and put it on the Tom's3D live channel. We'll see how you guys like it. We'll see how it goes. So please, no big expectations for today. Anyways, yeah, we're gonna try to figure this out. The machine is built. The machine is still pretty solid, I feel like. So the only thing that still needs to be done is figure out the software, figure out the cam. I did give it a go just a few minutes ago, the official recommended software tool chain. So I think I'll stick to that. And yeah, we'll see how it goes. One more thing, these shirts, Roar and Rib, I'm not wearing two shirts. I'm not wearing the other one underneath this one. But these shirts you can get right now. They were originally exclusive to my Patreon supporters. They got, or they, not everyone, but a bunch of my Patreon supporters got these shipped to them for free. So again, huge thanks for the support on Patreon, and this is just a small way for saying thank you. But you can now buy these out in the wild. I set up a Spreadshirt shop, so if you want to get this or the Ribbit, aka the one with the actual frog on it, if you want to get that design, you can also get that from Spreadshirt. They ship internationally, and it's actually pretty cheap all around Europe and the Americas. So yes, that's out of the way. Links are in the video description. 15% off until Guy Fawkes Day, which is interesting coincidence. But hello 3D printer noob and everyone else joining in. That's a different 3D printer noob. Cool. All right, why a frog? Well, Chad is probably going to explain that to you. So, yes, this thing is built. So, where did we leave off last time? It did move. We did get movement out of the X, Y, and Z axis. I tried through the typical 3D printer toolchain, because this thing just has this little camera, so many cameras. This little electronics box in the rear here that just, can I take the lid off just to show you guys again? This overhead camera should be a lot nicer than it was the last few times. It slides off. All right, I guess you can see these few stepper drivers, standard Pololu style, and a small Arduino underneath that. So this is, you know, technically it is very similar to what we're using on our 3D printers. It does run Gerbil, but yeah, it does use the same G-code and serial interface as the regular 3D printer boards that we're using. It does have a few specialties because it is built as a CNC controller. So that is that, and it didn't work out too well with the 3D printer control software that we tried, or that I tried last time. The other issue we were running into, or I was running, why is it we? Well, I guess you guys are such a big part of these streams. The other issue that I was running into was the end mill selection. Now, this Makita router that is recommended, it does have variable RPM. It does have the little control wheel over here, where you can preset the RPM, but the collet down here is a 6mm collet. So any end mill you use needs to have a 6mm shaft, and I only have, you know, so many 6mm end mills, and most of them are pretty large. Typically 6mm, I use those in the manual mill, and that is perfect for that. But for this sort of application, you know, it is pretty rigid, but you can kind of see it flex. This as well. This isn't massively rigid, but it is rigid enough. But I'd be more comfortable using a smaller end mill, so I ordered one of these collets that is then going to adapt to, come on, to these 1/8 inch end mills, which are super cheap. They are super sharp. I should be holding it like this, I'm just realizing. They are super sharp, and here we go. And they're super cheap. You can get them from China in all different sizes and, you know, flavors, flute, 2 flute, single flute, whatever you want. The only problem is the adapter I got, you might be able to see it, is not an 1/8 inch adapter. So it was sold as like a 6mm, 4mm, 1/8 inch adapter, but if you actually read the description, it said, yeah, it's 4 to 6. The 1/8 inch we just put in there for you know, just to get the search hits. So this is a 4mm adapter, and I don't have any 4mm shaft end mills, so we are gonna have to stick with this one, which is a 6mm shaft and 4mm well, functional diameter, flute diameter, which should be okay in MDF. So yeah, what router is that? The thank you for asking, BGson. I can pitch the associate affiliate links in the description again. Makita something, I actually don't know. RT0700C. Links are in the video description below. If you want to grab this, that's international Amazon links, I believe. Should take you to the correct page for whatever country you're in. All right, so today is going to be mostly software. Print and adapter, that's not going to be precise enough, unfortunately. Run out and all, our 3D printers aren't that precise. So yes, today is going to be mostly software. We are gonna start with CAM. We're gonna use Kirimoto. No idea if that is the correct pronunciation, but Kirimoto is a very, very simple CAM tool, computer assisted manufacturing, which generates the G code from a 3D model, which is basically the same thing a slicer does for 3D printing. And it does spit out a G code file. It runs in Onshape, so yeah, that is, you know, perfectly within my comfort zone, I guess. I tried it. It's really simple. There are not a lot of options. There's not a lot of manual stuff you could do, but of course you could run this with Autodesk Fusion and the pretty epic and advanced CAM tools that are in that program. But yeah, we're gonna try it with Kirimoto first, and then we're gonna go with the officially recommended UGS, Universal G-Code Sender, through USB from the PC. So before we get into that, I did acquire some Dr. Pepper. People were saying, yes, it is available in Germany. It's freaking expensive. It is available, but it is freaking expensive. I you know, still can't live without it, or at least for now. All right, let's jump into the software part. Oh, cool. Well, I guess this is more interesting than why can't I? Okay, my camera switches don't work. That is fantastic. Let me just authenticate this. I mean, by the way, 2-factor authentication, if you're not using it, use it. It's just, it just makes so much sense. All right. Why? Let's lock this real quick. And why is this visible? There we go. So, what I think I want to try. So last time we tried to print a, do I want to refresh this? No. Last time I tried to print a, or mill a CNC'd YouTube play button, just a simple 2D shape. This time I think we're going to jump right into the 3D milling, or we could try the RockShox lower seal tool. I guess, well, I guess either one is going to be fine. Let's start with a more complex one. Paid promotion for Dr. Pepper? Nope. I wish. Yeah, still fantastically weird taste. All right, load. There we go. So this is the tiny play button that is up on this button, up on that wall right there, the tiny one that I printed for 100K before I get the official one from YouTube. And if we check out how large this, there we go, Logitech mice. If we check out how large this is 11 millimeters wide. No, get. Okay, we need the full screen real estate that we have. 1 pixel? Seriously? Gonna give me a single pixel too? There you go. Okay. Now, okay. There we go. So from here to here, this is 11 millimeters. This entire thing is 11 millimeters wide, which is not large enough. Since we're using a 4 millimeter end mill, this is barely gonna spit out anything. It's just gonna be a little tiny blob. So yeah, not the best thing. I did have the transform in here to scale it down. So let's just suppress that, or whatever the correct terminology is. Roll that feature back. And now, if we actually grab these 2 points again, yes, Onshape is a free CAD tool. It is cloud-based. You can use the full functionality for free as long as you publish your designs. Publish as in it's publicly visible. So you get everything for free as long as you share. I'm okay with that. And I like it a lot. But Fusion, also very good software. So 55, that sounds a lot better. So how this is going to work. So Kirimoto runs as a plugin, as an application within Onshape. So it's not something you have to download or something you have to separately install or sign up for. It's just within the Onshape Cloud CAD. So this is still in the browser, still all browser based. Let's see, and this is basically the entire CAM program that we have. Mic rubbing. Is my mic plug not in all the way? Sorry about that. Please do keep me posted if the audio quality is subpar. So yeah, this is all browser based. This is still, you know, within Chrome. You see, I just downloaded GRE. So yeah, all within here. So let's go ahead and configure this thing. So it does have the CNC Mill 1 as well as the Xcarve and the Shapeoko and any generic Linux whatever CAD, but you can use the Xcarve, but you can also use the CNC Mill 1, which has the width, depth, height, etc. 1.75 millimeter filament. That's interesting. Already in there. I guess it doesn't discriminate between printers and mills, which could lead to some well, after some time you can't edit project anymore if you use FreePlan. I've not run into that, but yeah. So that is pre-configured. The Mill 1, that's already in there, so that's good. Let's check our tools. Where's our tools? Okay, we're in FDM printing. Let's switch over to CNC milling and actually get the correct processes here. And now we also get the tools selector. End mill 4mm. I've already pre-configured that. Actually, on another PC. That's also the other cool thing about using cloud stuff. I tried this out real quick on my desktop editing workstation before, and you know, since this is all in the same Onshape account, it automatically gets synced to other projects. So you set it up once and you can use it on any PC, any platform, you can even use it on your phone. So that is fascinating. 4mm end mill, that is correct. 4mm flute diameter and 10mm cutting edge length. I think that is even longer than that. I think that's even a 12. Shaft 6 and 10 sounds about right. Save. All right. So the part is in here. It is arranged, so we could move this around, I guess, but we really don't have to. Let's go through our passes real quick. So we've got shit. I'm losing track of chat already. Hello, CNC Kitchen. Good evening. And who else is here? 3D Maker Noob. The real 3D Maker Noob this time. Hey there. All right. Didn't want to do that. Okay. Let's see. Roughing. End mill quarter. That's not the one we want. We want the 4mm end mill. So roughing is just the first roughing pass where it just leaves a tiny bit of material. It goes relatively fast and it just hogs out as much material as it can. It does the roughing. So the first rough pass, and then it takes a second pass, goes around the same geometry again, but this time, you know, mills for a finish, mills for a optically pleasing finish on the surface. And that's typically a bit slower and with a lot less material taken off in a single pass. So yeah, 3D Maker Noob. Yes, there is another account called 3D Maker Noob in chat. There we go. I was wondering about that. It was like, that's first of all wrong location geographically and the wrong thumbnail. All right, spindle RPM. We don't have a controllable spindle RPM, so that doesn't matter that much. Step over. So that's going to be a 2mm step over. We're mostly hogging out the full width, so this is also not going to matter. But 2mm or half the diameter is fine. Step down 2mm. Decent. 1000mm per minute feed rate. Reasonable plunge rate. This might be a bit too fast. We'll just see how fast it is and we can then yeah, tune it down if you have to. So leave stock. This is where we can just leave a bit left over for the finishing pass, and I'm actually going to set this to 0.1, even though I don't think the tolerances on this machine are good enough to actually leave 0.1, but we'll see. How to generate so much money with Patreon? Make content that people find useful. That helps them. That's how things work. And if you make stuff that people appreciate, then they are usually up for supporting that. And show your appreciation. And I do appreciate every single patron. So, right, finishing. Let's not drag this out longer than we need to. We're already, what, 20 minutes in? Come on. Spindle RPM, again, doesn't matter. Step over 0.5. In finishing, it's not going to be, you know, step over won't matter as much either. Step down 3mm, reasonable. Max angle, okay. This is going to be some internal value. Okay, plunge rate, again, reasonable. Let's slice this thing. We're not going to do any drilling. We will enable the tabs, and I'm going to show you what those do in a second. There's a bit more down here, but for now this doesn't matter. So, right, this is our toolpath. We can actually scroll through what this thing is going to do. So, it's going to hog out a bit up top, and you can actually see this is slightly curved up top. Let's just show you again right here. There we go. So this is a slightly curved top surface in both ways, which is impossible to accurately mill with a square end mill. So the end mill has a geometry like this. So if you route that over a rounded surface, or a surface that is supposed to be rounded, it's not going to be perfectly smooth. Kirimoto is trying to approximate that though. So this is what we're seeing here. Just the roughing passes. There we go, and then there's the finishing, which crosses over the entire part in one direction and then in the other again. And this should actually, looking at how fine this grid is, this should actually give a relatively good surface finish. So yeah, Took about 6 hours to get out scaling call. Right. So this looks decent. This looks decent. And again, down here, if you head over to preview, we just get a. I don't quite understand yet what preview does. I guess it shows you the moves as well, but it's basically the same thing. So cutout tabs. Let's disable these real quick and slice again. And look down here. These are now continuous lines. So where it cuts out the button from the rest of the material, because we are cutting this out of a piece of MDF. This right here, this is, I can't move this by hand. So let's switch over to this. Ah, there we go. So this right here, this is a piece of MDF that is clamped to the Delrin base, and then another piece of MDF that is screwed to it. This is supposedly our workpiece, and this is just our waste plate that we can mill into and screw into and don't have to worry about it. So yeah, this one should be untouched, the Delrin base, and this one may get cut into. Just going to check real quick how deep that button is actually going to mill. And this is our actual workpiece. So yes, this is what we are going to be cutting out of. And if you actually cut out like a pocket like this and cut all the way through it, the inner piece is going to be loose. And if you actually look at the order that this thing cuts out, right here, first operation. So it goes down all the way, boom, and this thing is cut out. This would be loose. So you can enable tabs, and what tabs do is they basically just leave, there we go, leave a bit on each corner. There we go, 1, 2, 3, and on the opposite side as well. Leave a bit of material left over and don't mill this out. So that the rest of the part has something to grab onto to the to the rest of the stock. Thank you for the $20 tip, Victory Road Performance. Intake, what material would you recommend? Temperature is 100 Fahrenheit. 100 Fahrenheit? Is that, how hot is that? That is not very hot. Intake component, PETG probably, prints relatively easily, and 100 Fahrenheit, should easily take it, I guess. 32, well 32 is nothing. PLA would even work, but in the sunshine, the problem, okay, let's answer that real quick because I think it's interesting for pretty much anyone. I'm slightly out of focus, right? Ah, interesting. PLA is fine at 32 degrees. It's functionally okay. The problem is if you're printing automotive parts, it is going to be installed in a car, and people have reported that if you just leave components, 3D printed parts on your dashboard just in the sun on a hot summer day, that heat is going to be enough to deform PLA. And I can totally see that. It might get up to 60, 70 degrees or something, and that does melt or soften PLA to an extent where it just deforms a lot. So yes, PETG is probably your best bet. And for something like an intake component, which is going to have some bulk probably, it's much easier to print than ABS. Of course, you could go down the ABS ASA route, but well, if you can print it, if you have an enclosure, etc., that will also be a good choice. Cool. All right, so this is the print. We're leaving tabs. I think I want to leave these tabs a bit wider. 5x5 millimeters doesn't sound too, large enough for me. And let's actually jump back into the button file real quick and see how Z 9.4. So this should actually, yeah. My mouse is not working right. So this should actually just fit into the default or into this 10 millimeter thick MDF plate. I would like that. I would like that a lot. Okay. The backlight on the lovely blonde hair. I might be able to give you that. Hold on. There's the backlight. I think this is on autofocus. Yeah. Okay, that lighting setup is horrible. Sorry. Okay. Okay. Engine bay, 200 Fahrenheit. Yeah, that sounds a bit weird to me. Okay, let's jump back into Kirimoto. So this is sliced. I'm wondering if you can get some sort of a carve time estimate, I guess, but maybe not. So export. We can use the G-code center that is built into Kirimoto, which is a browser-based thing, but supposedly that doesn't work too reliably. Bytes, 255 kilobytes. We can send it to Octoprint. That's nice. Gridprint, not heard of that, but Octoprint I definitely know about. So download that. .nc. Let's actually just save that to E. There we go. All right, and let's jump over to URGS. Where's our URGS? There's our URGS. And start up the URGS. 24 hours? Build time? Hold on. Oh, estimated mill time, 24 hours. Well then, should we mill that? Should we mill that? To follow up on Ian, he prints ABS without an enclosure, and it sticks to his bed because he's using a surface that it sticks to. Yes, but the problem is if you have ABS in an open air environment, and unless that environment is hot enough, you're going to get a layer splitting. It's not about getting it to stick to the bed. It's not about keeping it from warping. It's actually keeping it from pulling itself apart. So enclosure always recommended for anything that has styrene in it. Does ASA? Yes, the S in ASA is also styrene. So, okay. All right, 24 hours, maybe not. We could try it out to just get the movement dialed in. Let's do 0.4. The cool thing is we should be able to hop over to arrange. Can we delete this? How do we delete this? Clear. Ha! Import, and we grab the same part again, and it should now be smaller, right? Yes. And this is still 4 hours. Holy crap. I guess that the longest, and it has the tabs. I guess the longest part is the finishing up top. So if we take out we can't disable the finishing. If you make this flat up top, then it should be a lot faster. So let's actually get rid of the suppress of the curved surface right there. Cool. And make it a bit bigger. 0.6. There we go. So it's now flat up top, so it won't have to do the entire, you know, this scanning basically up top. Clear, import. That didn't clear. Now we have to be in range. Okay. How big is it? The part originally was 55 millimeters large. The one we... it still does the scanning. Come on. What is that? Contour finishing. We can linear. I guess that's that slice. Here we go. Still 5 hours. Why is this still 5 hours? This doesn't make sense to me. Why 5 hours for... Okay, let's actually just try. Let's just download this. 3CEN. Okay, whatever. Let's download this. Let's plop it into Universal G-Code Sender. Yeah, it's probably wrong. I think so too. Let's plop it into here and just see what it does. If it's too slow, if it's too slow, if it just creeps along, we can always increase feeds. If it does something else where it's like just spazzing out, we can fix that too. But let's just try this. Let's just see how fast it goes. UGS also has an estimate. That is good. So let's try that. There we go. So file, open G-code file. And why is this the old? So where are we getting an estimate? I've not used UGS before. Well, I guess this is the point where we there we go, where we connect things to USB and power, preferably. Is there an emergency stop? Nope. Nope. Emergency stop is pulling the power. What I'm going to do right now is I'm going to dry run this. I'm not going to turn on the actual spindle, the actual Makita tool in here, and I'm going to lift up the tool far enough so that it does not, so that it doesn't actually mill anything. So if it, you know, starts to do some weird stuff or try to move through material too fast, we can always just stop it, adjust it without breaking the tool. Let's snake some wire through here. Click connect at the top left. Yes, I want to give it power first. Then I shall click connect. So this is plugged in. Is there any sort of an LED lighting up in here? Doesn't look like it. Let's see. Are we on 96? I don't know what we are on. Port busy. What? Guess we have to select a port. There we go. Are we on 9600? Are we on 9600? I guess we're gonna find out in a second. We can Z+. We are not. Grubble has not finished booting. Okay. A 20-hour mill job only took 45 minutes. Okay, so the here we go. That sounded better. So our motors are engaged. Yeah, so the estimates in Kitamoto apparently are quite far off. Won't the clamps get in the way? Let's center that. No, because we're going to be moving within a, well, within a 50 millimeter left-right range. I'm going to center it onto the workpiece. I'm going to center the tool onto the workpiece, and then it should never move into these clamps. So sides are missing. It's not going to move into, it's not going to move out of the workspace. So if we have this, it's never going to move outside of this 36 millimeter envelope. So I guess, yeah, I'm not going to home the machine because the machine doesn't have any end stops. But I will try to manually move it. No, like that. Why are my hotkeys not working? But I can try to manually move it to our desired position, which is dead center on that workpiece. So where we knew after x plus, what are we? X, y, step size 1. That is either really slow or, yeah, 10. 10 what? 10 bacons. Let's try 100 bacons. Okay, something moved. Yeah, 100 bacons is better. Let's do 1,000 bacons. Yeah, here we go. 10 millimeters. Millimeters? I assume this is millimeters. Yeah. There we go, that's roughly centered. Y plus. Okay. There should be video here. Oh no. Oh, there's video there. So this is centered, but this is still way too close over the over our workpiece. So if we started something now, it would just run into that workpiece and crash. So let's move it up just a bit. Let's actually also move it up 10, like 20. There you go. Okay. We're gonna reset 0. I assume that is the, yes. Reset, yeah, same thing. So we are now reset and it starts in the bottom left. This is interesting. I thought it would start in the center, but let's just run this. Let's just see what it does, I guess. Is it just me or does the box amplify the sound? Yes, but the sound the steppers make isn't the biggest issue, the biggest source of noise on this machine. It's the router and it's the vacuum I'm going to be using, so yeah. Yeah, usually, here, it's no point if you don't see what I'm doing. Usually a cam tool has a way to set 0, and you either set it in the center somewhere or in one of the corners. This is neither. I guess this is one of the corners of the finished piece. We might be able to set 0 somewhere in the devices setup. Or origin center. Okay, better origin is center. Stock width depth height. Okay, I guess we could set it, but origin center again. Not sure how this interfaces, but still the moves are there. Let's just try and send this. Ready? Checking all the perspectives. Go. An error was detecting while sending M6T3. Unsupported or invalid G-code command found in block. Streaming has been paused. I guess if it's only a one-time thing, then I'm okay with that. So I'm not sure how loud this is for you. To me, this is louder than my own voice right now. So yeah, obviously amplifying stuff a lot, but yeah, again, not that the biggest source of noise there is going to be. So it is moving along quite nicely. The accelerations are quite slow. Let's just see how much torque it produces. Not that much apparently, since I can... Yeah, I can get the motors to skip just by applying some pressure here. We might be able to tune that in with the current on the driver spec here. These are standard A4988s, I believe. Yes. And... what is this? X, Y, Z? Yeah. We might be able to just increase the current a bit on these and get a bit more torque out of it if it actually starts skipping. I guess we're just gonna have to listen to that or for that, and yeah. But for now this should be okay. So if anyone has a clue for where Uggs would show me an estimate, here, I guess down here. 2 minutes, one minute left. Okay. So rough estimate 3 minutes total. And what? Kirimoto estimated 5 hours? Well. Let's see, and that's X. Yeah, there's not a whole lot of not a whole lot of torque left there, but we're just gonna try. We're just gonna see how it goes. Just for reference, let me plug in the router, because right now it's not really hurting anything if I turn it on. How do I turn this on? Ah, it has an on-off switch on the side here. So let's go to the slowest setting. So this is 1. Yeah, that's the router enable. Are we clipping? We're probably close to. So that's the router on full speed. Something's flipping, but if you were saying that the motors were loud, yeah, this thing is louder, definitely. Like, this is how far away I am from it right now. Like, you know, it is loud. It truly is loud, and the G-code has finished. By the way, were you able to hear the motors out of that? I don't think so. I do not think so. I can turn down the rec level. The thing is that's actually gonna make the router louder for you because I have a compressor on it. So yeah, what I was saying is the motors aren't the biggest issue. Like, that was, I started out on the slowest setting and then turned it up to 6, which is the fastest one. So yeah, there is quite a bit of extra noise from the motor, compared to from the router spindle motor compared to the stepper motor. So don't worry about how loud these are. So yeah, no motor sound now. Yeah, I can turn it back on. Ready? 3, 2, 1. That's the lowest setting, and this is the highest setting. So I do have ear protection here. I do have hearing protection here. I will use that when we actually get to routing stuff, since we also turn on the vacuum in a second, and that is going to add some extra noise. So if you look at the software again, so this took 3 minutes 15 seconds to complete, which is vastly quicker than the 5 hours and 6 minutes the Kirimoto suggested. So I guess if we had the other one that was a 24-hour milling pass, I guess that would be 20 minutes or so. So, well, yeah. So actually, let's do that. Let's actually mill the real deal. I don't want to unsuppress fillet. That's good. I don't want to, you know, leave out this beautiful play button that we can mill apparently in a decent amount of time. Arrange, clear, import, button part. I downloaded it already, the entire thing. Isn't the mill moving too fast? No, I don't think so. Hotkeys. Sometimes hotkeys work, sometimes they don't, which is weird. Then I have to jump back to manual clicking stuff. In MDF, that should be totally fine. That should be more than okay. I'm gonna reslice this because I'm not sure if I actually downloaded it with the wider tabs. And we're gonna enable the... Hold on, that's the wrong ones. We're gonna enable these two, linear X and linear Y. Actually, I think we can leave out one of these. We can leave out the linear X and just do it this way. Or that, what? Y. That's X. Interesting naming. Okay, because if we do it across, it's just gonna make the surface ever so slightly better. And for this sort of smooth surface, I don't think we need the 2 passes. I could be wrong. I could be totally wrong. But Let's try, and it is going to try to cut out the center play piece, or play indentation. 20 hours. Pimsel. Cool. What feed rate? 1,000 bacons. 1,000 millimeters per minute in Kirimoto. So where's our load file? Open G-code file. This one. Okay, so where is... That is interesting. So that's actually, if we actually look at what this shows us, so let's jump back and forth. So this yellow marker right there, not the white one, that's my mouse, but the yellow one, that's actually showing where the tool is, where our router is in relation to the work we're going to cut out. So if we move right here, this should actually move the yeah, this is actually going to move the indication of where our tool is. This is pretty nice. So we could actually move to the center and just get an idea for, that's roughly the center. So if you look at this right here, this is also roughly in the center of our part. So we can just jog down the entire part and see if it's actually going to fit inside what our machine can reach. So like on the right side here, this is perfectly fine. This is, by the way, that there's plenty of space between here. On the left side, if you move all the way to the left, might be a bit close with that clamp. We are not going to collide. So this is it's never going to go there. So this should also be fine. Just can I manually jog this without? Yeah. Someone is saying I'm skipping steps. I am going to turn up the current just a tiny bit. Just a tiny bit. If I can find a suitable screwdriver. This might be one. Because these drivers are, let's just check, cool to the touch. Yes. I'm gonna turn these up ever so slightly. Not measuring for now, since measuring the voltage on these voltage dividers on the drivers right here isn't really a reliable way of estimating a current, because there are a few different things that go into what that voltage is going to actually mean as far as current goes. There's going to be the sensing resistors. There might be different voltage dividers behind that potentiometer. There's a difference between the Pololo drivers and the step sticks. So what is 0.8 volts reference on a step stick means something completely different for a Pololo driver. So that's not really a reliable way of measuring that. So my mic is rubbing against something. I'm sorry about that. I don't know what it is. My mic is actually right here in my glasses. There is no way that is rubbing against anything. It might be the cable. Mic is still, or connector loose. Yeah, it's probably connector loose. I'm gonna mute that for a second. Let's see. Are those just NEMA 17 motors? Yes, they are. They are Anycubic motors, actually. And their rating doesn't matter because it only depends on how much current they're getting. Please wear a mask. I might... We'll see. I'm going to use the vacuum first, and then we're going to see how much of a mask I will need to use. So one more thing we have to do before we can get milling here is we have to set the Z height. So XY is fine, is decent, I'm hoping. If not, we're going to crash something. So this is still way too far up. Right now, the machine thinks it is at Z1, so 1 millimeter above our work surface. If we reset, if we reset this, it thinks it's at 0, and it is obviously not at 0. I think there's a feature where we can just type it in and just say, okay, you are now at this height. But what I'm going to do is I'm going to lower this until we are touching the surface ever so slightly, or I might just let it skip a few steps. We'll see. Actually, I'm just going to let it skip a few steps. Nah, I'm not that much of a sadist. All right, so turn this down to, I'm sure there must be a better way, like what Prontoface does with the variable step lengths. That's touching. That's actually perfect. So -24, reset. Now the machine knows, okay, this is, yeah, this is your new 0. If you move up millimeter or 10, even though the machine moves up, the software still keeps track, the firmware still keeps track of where it is. So as soon as this G-code tells it to go to 0, it's actually going to move down. So yeah, can't you move it manually? I guess I could use the, I could turn the lead screws manually, but they are under tension, that they are under current, so it's going to be yeah, it's going to be quite difficult to turn. So this is going to be the actual milling run. The mill is in there. It's a 4mm. It's what we set it to. We're going to turn on the spindle. We're going to set it to a relatively fast speed for MDF. Ah, nice. RIP headphone users, I'm sorry about that. This thing needs to be, did I just move it? I hope not. This thing needs to be going. Yeah, vacuum, mill, cameras, Dr. Pepper. Don't want to get any dust in that. All right, so let's go. Turn this thing on. Vacuum. Light flickering, that's cool. And let's go. An error was detected. Keep going. That's the play icon. Something's milling. Stop. Hold the power. No. Okay. Okay. First of all, I should probably get a mask. Everything is dusty. My vacuum's probably clogged up. Let me check that real quick. Like, this thing is probably... Oh yeah, there's a... Yeah. Should have cleaned that. Shake off some dust. That usually helps. Yes, it does. Okay. What was happening? So what I was seeing was that the Z-axis was moving down. Let's actually have a look at... we can't. Pfft. Shit, this is going to be so dusty when we're done. So what actually happened was that I was seeing the Z-axis move down, but not up again. So we were actually getting pretty solid cuts. Like the the cuts were chugging along pretty nicely, but I think the Z-axis was losing steps somewhere. It's either mechanical with some coupler sliding up or down. There is a coupler back here, but I don't think that's the problem. Let's see. Shit, everything is dusty. Stop. Okay, I guess we're disconnected. Let's unplug USB just to be safe. And give it power again. So disconnect, yeah, whatever. Port not found? What? Let's close you up. So it might be it might just be the driver for the Z-axis being a bit too weak. It's probably the one that needs to be set to the highest current out of all of these. This version is beta, yeah, whatever. COM8 connect. Port not found. Oh, not plugged in. That's why. The first cut is the deepest, yes. Z was moving down slowly as you were adjusting the spindle RPM. Okay, so there's definitely something slipping. Connect. There we go. Let's see how Z moves. So yeah, see how far we were in there. I'm actually impressed how well the that little mill was holding up, considering we were doing cuts that were probably, I don't know, how much of a cut depth was this? 6 millimeters? Probably 5 or 6 millimeters at a decent speed, at travel speed. So yeah. Z motor was not powered when you turned the router on. It should have been powered. Okay, let's actually just retry. Let's move this thing a bit in the other direction. And let's try milling this. So that's going to be 0 that we're just sitting. Let's try milling this in the front of our workpiece. We can always screw down a fresh piece of MDF. So hold on, if you say reset XYZ, okay, that's going to be center. So we actually need to set the center of our work. Gotta remember that. Can't just run it to the front left, so we actually have to run it to somewhere around the center. Too far. That looks about right. One half of the tool diameter is the same cut depth. I won't go more than that. Well, MDF, it's just MDF. You know, it's not anything. If you're doing aluminum, if you're doing steel, yeah. In steel, definitely don't. At least on this sort of machine, don't do more than half your tool diameter. But I mean, for MDF, that's touching, so that's good. So reset 0. This is going to be our 0 point. What you're seeing right there, that is our 0, and we are going to be milling the logo around that. Now the question is, why was the Z-axis dropping? We can move it up quite a bit. It's going to move down once we start we run the G-code. This one. Let's see. Can you jog up some this time and re-zero? Re-zero? Thought it was over the piece and was trying to... Okay. Don't do steel. Yes. Maybe with a tiny end mill, but... Not with this one. Not router clamps. What router clamps? This one? Oh, I just what? This is interesting. This is quite interesting. Is that motor off? What? What is going on there? Oh, I just pulled it off the rails. Okay, that motor current is way too low. That is way, way, way too low. I don't know what these drivers are, but... Okay, that's better. Ooh, so these drivers, they're not anywhere near my other drivers. Like, you can crank up the, let me just turn this around. Like this. So this is one of the, I guess, Chinese CNC boards. There we go. CNC Shield. That's what they are. So the drivers were set to, or the driver potentiometers, which way was it? To the left, I guess. There. So that is center. Boom. Zoom this. Maybe now focus on the right thing. Oh yeah, look. Good Chang'e capacitor right there. Chang'e. So yeah, this is the center position. And that's how I think all three drivers came. No, they're actually way down. They're like 90 degrees to the left. And typically, like on most Pololo drivers that I have, the position where you have the, I just shorted something out, where's our flat? Our flat is facing top right now, so that position is usually just okay. And when you have, you can see that clearly. Having that flat opposite from those two solder taps on the bottom, that's the center position, and that's usually just fine for most drivers. However, on these you actually have to turn like 90 degrees over for it to give you some decent torque. So again, that's the same thing I was mentioning before with, or not, that's the same thing I was mentioning before with different drivers having different levels of reference current. Is that motor off? Considering I can still move it around by hand, is this even doing anything? Like like what? Use your voltmeter. I might. You might actually get some decent readings out of this. Let's see. Everything is dusty. Oh shit. Everything is very dusty. Ground. Where do we have a ground on here? This is going to be interesting. Okay, so you guys can, yeah. There? There, okay. Z-axis, that is at 0.94. That should be way better than what we need. Let's see, this is one of the axes that's at 1.03 and that's at 1.14. I can still move the Z-axis by hand. And the motor is happily turning along, definitely. So, not sure what's up there. a bit extra. This was at 0.94, now this should be at 1, yeah. Let's jog it a bit. It's interesting. So as soon as there we go. So I can move it, it moves up, and if I apply pressure, and as soon as the move ends, it just drops down. It's almost like there's a... See that? As soon as the move ends, the current is gone. It's like... It's like the motor immediately shuts off or something. Step enable timers. Does anyone know the G-code to reset that in Gerbil through the console? Check enable pin. That's probably turning off. I don't know which one that is right now though. Yeah, enable isn't staying put. Does anyone know the or I might just Google it. It's definitely a driver issue. Wait time is idle at 0, most likely. So Gerbil wait time M666. That sounds reasonable. Yes, with Marlin firmwares you can set the firmware to not disable motors. I'm not sure how Gerbil handles it. Configuring Gerbil. Let's just figure this out together. So, getting started. That can is also dusty. Step idle delay. Let's just check what we have. Here we go. So $. Step idle delay 25 milliseconds. That sounds too short. So considering this is and Captain EEPROM, do you have to save this? $X is value. So every time your steppers complete a motion and come to a stop, Gerbil will delay disabling steppers by this value. Or you can always keep your axis enabled. Yes, we need that by setting this value to the maximum of 250. Why is 255 the maximum? Okay. Just to repeat, you can keep all axes enabled. This seems to be a common issue. So let's actually apply this. Boom. And now the stepper motor should stay enabled. Do we have to save this somehow? In Marlin, you have to save it to EEPROM. I guess it's immediately saved. Let's just, as long as we don't power it down, it should be okay. So let's retry this. So draw controller Z plus a bit. And now you can actually hear the motor staying put. That is fantastic. So this fan-like noise right now, that's the actual motor staying put. And I'm pressing down pretty hard on this. This isn't going anywhere. Awesome. Okay. There's a bit of backlash obviously, but gravity and all. Yeah, this is not going anywhere. Okay. Got it figured out. Perfect. This sounds like it's getting a lot of current though, and I don't want these drivers to overheat, so I'm gonna turn it down just a bit. Just like the tiniest bit. All three axes. Right now this is still, I guess I could hammer it down Ugh. Now, XX is also rock solid, not going anywhere. Okay, so that we need to, we just had to adjust. Cool. Fixed. Let's try this again. So, rotate this guy around so you guys can see something. There we go. Now the vacuum should be a bit cleared up. I don't think it was vacuuming all that much. Should we put on the... There we go. By the way, this shirt is awesome for wiping down acrylic fronts. If you want to get one just like it, check out the links in the video description where you can get these on Spreadshirt, custom made as a shirt, as a baby napkin thing, as a baseball cap, on a mug, whatever you wish. Yeah, you can now get these. Link in the description. Cool. So, reset zeros. It thinks Z is at 38, so move this up and let's just check that it's actually moving up and staying up. And we can press down on this all we want. It's just gonna flex a bit. Yeah, perfect. None of these axes are going anywhere. We are still in the roughly zero position right here. So that's still where we want to mill. So let's let's try this again. So I did make a few checklists for stuff like live streaming starting, lights, get my screen set up, get it all published on social media, get the stream public, enable chat, do all that. I should make a list like that for the CNC mill. It's almost like, you know, taking off with a drone or with an airplane. Just let's take off with the airplane, shall we? All right, so that's going. Vacuum's going. Let's see if I can get away with no mask. Okay, there's our error again. I don't know why that is happening. And that looks a lot more reasonable. Yes, and it's actually clearing the surface right there. Look at those cuts! This is looking fantastic! Look at that, depth of cut, perfect! It's clearing the surface! The edges look a bit ragged, but this is looking very nice, in my opinion, I think. Turn the speed up, what? Hard speed? Spindle speed is all the way up already. Whoops, that flew out. I don't know how to do it in Gerbil. I don't know how to do it in Gerbil. Again, I don't think the 20-hour estimate was anywhere near accurate, so... Am I doing climb or conventional? I think this is conventional. I don't know what Kittymoto is set up for. And there is so much dust! is an incredible amount of dust. Like, holy. Ah. Shit. I'm trying to get the camera up further, but I can't. So, just to get you a reference for how fast this actually is, yeah, it's reasonable touch speed. And yeah, I guess I'll have to take this thing out so you guys can see something. Okay, give me a second, I'm gonna get me a respirator. This thing is getting incredibly dusty. Ah! Yo, quick trip over to the workshop. It must be weird hearing audio from a different room, but that's, you know, modern technology and all. The only thing is now, as soon as I put this respirator on, you're not going to be able to hear what I say at all. It's just gonna be over. Ah. You guys say you're gonna be able to hit me anyways? I'm not sure about that. We'll see. So, if you're wondering, the CNC in this video, I'm not sure. Like, you're probably a bit more dust extraction than what I have here. This is all super dusty right now, so yeah. This definitely needs some sort of a better dust collection system. But the cut is looking fantastic, that's good. Moving parts. I gotta feel it's almost pointless to talk at this point. I might as well man the camera. There we go. Oh yeah, that is. That in the whole thing better days.
What are you gonna do about it? I thought the entire thing would just go faster speed-wise, so yeah. The thing is with these large end mills, you do not want to run them this fast, but you still need a spindle that can go somewhat fast if you want to use a tiny 1/8 end mill. But you guys probably can't understand the thing. Why am I even trying? So this is the linear XY, the Y path I'm doing right now. It's just cleaning up the surface real well. Okay, I'm gonna quickly check if we have any more of those end mills. And yes, we should increase the feed rate a lot. Nope. I might have a 6mm somewhere. 6 by 6 by something. Yes, this is good. 6 by 6. That one's empty. No. Okay. What's that? 6 by 6. Okay, we have plenty of 6mm end mills. Okay, one less. But no more of the 4mm one, which is unfortunate. Okay. Back to the studio. More end mills. More end mills. This is it. It was 6. Good. That's it. I'm going to be past that. I turned that off to save some time. So, no extra pass. Clear ballpoint, yes, but only 1/8. I think we're done. I think that's it. Yes. You done? We're done.
Okay. Ah. Ah, my hair has an interesting texture to it. Okay, so as it turns out, why am I screaming? Why am I shouting? So it turns out the 20-hour estimate that Kirimoto gave us was... What's up with that? That's why is that so empty? Turns out the 20-hour estimate that Kirimoto gave us was a bit far off. So this was 11 minutes, according to Uggs. So let's see, can we jog this forward? Oh, thankfully it's moving to a 1mm safe height. All right. MDF dust is carcinogenic. Yeah, what isn't these days? So there is our YouTube play button. I'm quite happy. So we did do. So what it did was it did the Z-planar contouring, where it just moves down basically one Z layer at a time and erases or deletes these edges, and then it did the. I guess it would be X continuous passes that it did right here, and this actually gets the surface correct since it moves the Z-axis at the same time up and down, so it actually does that 3D move across the top surface right here. It would have also done another one 90 degrees to this, so in this direction, but I did skip that, and since we're seeing right now, that wouldn't have removed it wouldn't have removed a lot of material anyways. Like, look at this. This is pretty much good enough, I'd say, at least. It's almost perfect. You could go with a smaller step size or with a ball nose end mill, but I don't think that's even necessary. You go over this with an 80 grit sandpaper and it's going to be pretty much perfect. These corners you can take out with a chisel, just square them out or triangulate them out. And of course these tabs right here that right now hold a part in place, you can saw those out. So yeah, how am I gonna get this out? I guess unscrew it and cut them out. Now the end mill, yes, some of you noticed it did burn. It is quite black, it is quite dark, just like my soul right there. If we could get this to focus, probably not, but yeah, there we go. Come on, there. That has seen some better days. It has, if it's black, it's probably been glowing for a few seconds. That's just the high RPM. We weren't feeding fast enough. The tool head or the tool wasn't moving fast enough through the material to actually remove material, so it was mostly grinding. So that's not too good. If it was a smaller tool, then that would have been the better choice with the high RPM. With this size tool, the low RPM is the better choice. And next up, we are actually going to be using the 6mm. If we're even going to be using, should we mill something else? Should we try the 6? I feel like it, even though that the dust isn't too nice right now, but we still have the 6mm end mill that we could use. If you say yes, then please do leave a suggestion of what we should make. So yeah, I guess let's grab the drill, the driver. If I can find the other blank that we had. I thought I had cut like 2 of those little MDF pieces. It could be anywhere. It could literally be anywhere. Give me a second. I'm just gonna grab some tools, and while I do that, why not go with the be right back hotkey? That doesn't work. Come on. Be right back. I have returned. Miller Tom's logo. Ooh. That is actually the logo, the animation you were just seeing, and the actual logo, which that is based on. That is an actual 3D geometry. It's an actual 3D mesh. I don't think I can turn that into something I can mill in the time we have right here. Try to cough up a dust cover. Fidget spinner. How much feed will I get out of these? It should be no music. Ah shit! I might have disabled that at some point. Since the motors now are staying enabled, we do kind of have to jog stuff the real way instead of just pushing stuff around by hand. So you might be able to see the dust cover in here. The high RPM, of course, also creates finer dust than necessary, so low RPM. USB cord. So yeah, lower RPM. Preferable in many ways. So it didn't go all the way through. Let's see. So there's our play button. Didn't go all the way through, but there's just a tiny, barely. Yeah, you can see I can just push it through by hand, where it just barely cut through, and right there it does. Yeah, it does show. So. These tabs right here, I might just have to cut out or grab the good old side cutters. We'll see. Trying to catch up on chat. Ooh, yeah, Simona, I do have that model right. Should get something to put under this. I don't want to cut into my fancy table. Old laminate. That's good. I'm not sure how I'm gonna pull this into Onshape and into Kirimoto. There's one. Where's the other? Come on. There we go. This is probably not the best way to cut these out, but it's working for me. And it's probably not the best saw for this. It's probably not the best way to hold this saw, but I kind of like to think of it as it's like a chopping knife. It handles very similarly. And if I just hold it back here, it's like, yeah, you have this long, awkward thing. Why not hold it here? Glove, maybe? Use a chisel? I could. Then again, I don't know how well the... Cool. I don't know how well the logo is actually gonna print. Maybe let's try something else, something quick. So anything that we can get into Onshape, we can process. I guess I shouldn't use a metal file, but then again, I'm not really equipped for woodworking. Can I snip this off? Kinda. At least reduces the amount I have to file off. Aluminum this time. I don't know if I want to try this live on stream. Plus aluminum. I do have some aluminum blanks. They're either really big and really clunky, and a material that is made for milling, or there are thin and rolled aluminum, which is horrible for milling because it just smears and clogs everything up. The other thing is with the burnt out 4mm end mill or with a 6mm end mill in this setup, I don't think we're going to be able to do aluminum at all. All right, I don't have, I should have brought some sandpaper. Anyway, so the surface on this thing, look at that autofocus. The surface on this thing is actually pretty nice right now. So I feel this is good. If you just take a file and just lightly file this over, look at that, look at that. Those cut lines, they come right off. And there we go. So this side has just a few strokes of the file on it. I guess sandpaper would, there we go. You can see the difference right here. This is almost perfectly smooth with just a bit of post work. So yeah, this has been a pleasant experiment. Okay, aluminum would be a nightmare. Yeah, again, not with the 6mm end mill. With an 1/8 inch, I can definitely see this guy doing aluminum, considering how. Ooh, you can see this fancy key light right there. Ooh. Yeah, with a smaller end mill and with a proper adapter, I would. I can definitely see aluminum happening on this one. Just no issue, I think. Try normal wood. I do have some. Well, normal wood. What is normal wood? We usually have like, what is it, fir? That's our standard wood here, or beech. I guess that would make a nice cut. I just need to know what we should mill. Print another one from the or mill another one from the Prusa waste tower. The thing is hollow inside, partially at least. So we're not going to be able to mill that. Stainless steel? Nope, not going to happen. Delay on the top cam, I thought I had those calibrated. Acrylic, I also have acrylic, yes. But I don't think I want to do that on a 4-flute 6mm either. So again, this is the... We can either use the burnt up 4mm end mill again, or this 6mm. Come on, if you would focus, please. There you go. Or this cheapo 4-flute 6mm end mill. Again, I usually use those to cut steel. For those, they work beautifully, but yeah, not sure about wood. So Korean, there's a whole bunch of exotic woods that you can get. Of course, I also have some Kumaru, which we used for our decking outside. And I think, why is that wet? Is that oil? And I think that would also mill beautifully. Actually, do I have like a small bit of that stuff right here? I might. I actually have some rather large bits of that right here, which I don't want to cut up. Let's go with the beech. Buche. That, and we are also going to need a drill for that. Okay, guys, tell me what to mill. What to mill. So this cover right here, quite filthy. I'm not sure how much use that's going to be without a dust collection system. Without an internal dust collection system. Nameplate. Multi-material for CNC. I know a company that's working on something. So this is just a cut-off piece of beech that I have. I think it's beech, right? Buche? This is the right translation for that. Just flooded with water. Flood cooling? Yeah, flood cooling might work. Let's go a bit further on the outside. Mill the parts for a phone stand. So this is the amount of material that we have for size. So probably like a 2" by 2" square out of this at most. It's quite thick though. It's like 1 1/4, so 20, 28 or something. Okay, and some screws for this. Mill the shirt logo. Benchy. We can try and see what the Benchy is gonna look like if you throw it in there. Those are too long. Which means these should be the perfect length. Benchy birch, not beech. No, this is not birch. Birch is a Birke. This is Buche. So I think that is beech, right? Okay, I guess we can make a widget, a fit. So if we just line it up like that, it should be nice and square. Okay, I'm gonna screw this down and then we're just gonna check what a Benchy would look like. Can you mill a PCB? Someone's asking. Who's asking that? Musikkassette. Yes, you can. You can pretty definitely mill PCBs with this. Okay, that is nice and tight on there. Okay, quick sucky. All right, let's just see what. Wait a second. How am I gonna get the Benchy into Onshape? Let's check real quick if we can find a 3D Benchy step. STO, yes. Well, if it's download, if it's only an STL file, then we can't import it into Onshape, which means we can't mill it. There's probably other tools that can import an STL, and I know that. Well, what's it called? Estelcam does STLs, but I'm not sure if I want to set this up for the mill again. I guess I could, but it's not gonna be a lot of detail, especially since we are gonna switch this to the 6. Or is this? This is still reasonably sharp. This is still reasonable. If I can, there we go. So yeah, I don't think we actually need to switch over to the 6mm since this thing is still plenty of sharp. So Molequick Fusion C60, yeah, cool. 2D Benchy. SVG. Mill My Shirt logo. Yeah, the problem is, again, half sphere. It's fidget spinner. Yeah. You know what, Simone? Send me that step file. Let's figure this out. Let's get this going. Let's print the logo. This one. And print the logo. Mill the logo. It might be, there might not be a lot of detail in this small area. Skype, yeah, Skype should work. There might not be a lot of detail in this small area, but we might be able to... We'll see, we'll see. Let's just see how this looks. I'm sorry. It's just, I'm just so used to saying print when it's like an NC control machine that makes things from a 3D geometry. It's like, it's so similar. In fact, if we put a 3D printing toolhead as an extruder and a hot end on this thing, it would print. It will 100% totally print. While I'm waiting for the file right there, let's catch up on that. Mega Man Mike, thank you for the 5 years. I totally missed that. You need a beer after all that dust. Not a huge beer drinker, but thanks. And also, I did miss Alexander 2 hours ago. No message today. Well, thank you. Yes, so what I wanted to show you is, which is probably going to be hard to show unless we get it on this very camera. So, if you look at the motion system, so this is a triangle, or a triangle, an angle. It's not an angle iron. It's an angle profile in aluminum. So this has a lot of dust up top. Whole bunch of dust up top. There's another one of these profiles right here behind the spindle right there, oriented like this. And there's another one down here oriented in a, let's actually move that out of the way. Come on. There we go. There's another profile down here that is, you know, oriented like a downward channel. So all the dust that doesn't get sucked off or it doesn't get collected in some other way, that's going to accumulate right down here. And this is also where the spindle sits. Where the spindle, as in the trapezoid spindle that drives the y-axis, that sits right down there. There. Camera. There we go. That sits right down there, and you can see the dust that's accumulating right on the stepper motor that's sitting back here, and is eventually probably going to cake up this this trapezoid spindle. So I might end up drilling just a hole down here so some stuff can get out of this channel. We're gonna see. Cool. Is this one of the Chinese cheapo kits? No, it's the CNC. It's a US made kit. What's the largest build it can do? I think 220 by 1 something. It's on the website. Let's just give me a second while I figure out the step logo right here. Do I want to open this? No, I want to save this. Save as. Skype is horrible. Okay. Return to documents. Let's see if I can import files right here. Tom's logo, create public document. Exchange formats. Oh, will I start cleaning tonight, or am I going to leave it tomorrow? I'm definitely going to leave this for tomorrow. Like, not feeling it. Bottom channel should be upside down. Yep. But this is the way it's mounted. The thing is, if this channel down here, let's see, upload complete. There we go. If this channel was upside down, since you might be able to see it up here, since these wheels, since the open builds compatible wheels right on this side of the channel right here, they right on this edge. And on this edge down here, if this was, something's hot, this motor is warm. If this channel was upside down, the distance from where the wheels attached to this Delrin plate down here to this would be much, much larger, and there would be a large standoff between the, let's look at this, between the Delrin plate in here and, you know, where the wheels actually have a mechanical connection. So that would be super weak and probably not make for a very, ooh, wow, okay, a very usable connection. Okay, that representation of with the lines on there is quite interesting, but this is the file that Simone Fontana sent me based on my logo design. So this might be very interesting for the 3D carve feature. Yeah, okay. We will need, okay, where is transform? Transform, there we go. Translate by rotate. So first of all, we are going to need to rotate this about some z-axis. Let's use this as an axis by 45 degrees. Entities, this thing. So that it's square with our stock, because our stock, we're going to place it in here like this. Do you have a pen? I don't have a pen, but you know what I mean, like that. So number one, that is done. So re-enable planes. We can see it's now square in our coordinate system. Then we need to scale it to match what we need. So translate by, no, scale uniformly. There we go. How large is this right now? This is, well, I guess we could just grab the edge. No, grab this edge. There we go. 45. Ooh, that could actually fit. That could actually fit perfectly if I had some sort of measuring device, which I do not. Thankfully, the workshop is just next door, which is going to have, an ample supply of measuring devices like this fantastic one. So let's see, 45, is 45 gonna work? 45 might just be perfect, yeah, so we might be able to scale it up to 50. But then we're gonna have to center the tool very precisely. So 45 is gonna work. 45 is gonna fit perfectly on our piece of beach that we have right here. So add application Kirimoto. Size of the design versus size and shape of the end mill not really going to work. Well, we can just try it out. The T is still going to work. The T is still going to print mill, sorry. It's still going to mill nicely, so let's just try it. Crap. Is there a way where I can rotate this? Probably not. So let's rotate again. Yeah, so these layers are actually representative of what our mill looks like. So top surface, this is going to be our work surface on the mill. So let's transform this thing again. Say rotate. I'm going to do this entity around one of these edges. This entity, this axis. By 90, not 45. 90 degrees. What am I pressing? There we go. My laptop's not happy right now. Okay, pressed once too often. Cool, okay, so this is fixed, clear plate, and let's grab that again. How to get rid of the dust? Probably a mix of compressor and vacuum and, you know, wiping everything down. It's gonna be a mess. It's gonna be a mess. All right, slice. Still very interesting texture. Okay. So let's enable linear X for a single pass. This is just the roughing pass that is taking off some material. We're probably not going to see the exact geometry until... and we don't need tabs. We're not going to cut all the way through. We're probably not going to see the exact geometry until we actually give it just a light sand. This is going to be interesting. So it does do a bit of geometry right there. Let's actually enable the linear Y as well, so we get the passes in two directions. Yes, a ball mount, ball nose end mill might work better, but that's what we have right now. Yeah, and this is accurate, or mostly accurate, based on the actual geometry of the logo. Cool. Preview, yeah, looks okay. Export, again, 16 hours. That's not accurate. This is the Tom's logo. This is gonna mill for a while, and again, the beach dust isn't really that healthy, so well, we're gonna have to figure something out. Okay. And while we're at it, let's load the G-code file. So 0 is in the center of our part again, so let's actually mark that on our blank with a pen, which I hope I have somewhere. Pen, yes, so. So this is 45. We're just going to mark it 2.5 roughly there. And then center is roughly along that line. So if we get our tool centered on that mark, it should leave enough material on this side and over here so it doesn't hit the screw. It doesn't run out of material on this side right there. Chamfer the outside edges. Can't really do that in Kirimoto. We need something more powerful, like fusion. Now I'm not really sure about that end mill. I'm not sure if that end mill is gonna hold up. That was actually pretty close to perfect. I'm not sure if that end mill is gonna hold up, or even if it's gonna cut well enough for this hardwood. But I guess we're gonna find out in a second. So this needs to go just a bit further. Now that the movement right here with manually inputting the step size and then jogging it step by step, that is kind of tedious, gotta say. Universal G-code sender, yes, you might be universal, but you're not comfortable. Like, definitely not. Cool, but this looks like we are set. We are in the correct position. Right there. I will gear up now. We need to reset our positions on the software right there. So tool thinks it's in the center. That is good. And let's do one more cut. End mill should be okay. Use paper to home. Well, this is 0.5 millimeter up, so we might just get it 0.5 down. Oh, that went 5. That's cool. I typed in 0.5 and it did 5. Nice. 0. Do you have to do it with a 0 point? With a dot? Oh, you have to do it with a dot, even though right here it's with a comma. God damn it. Universal G-code sender. I'm already starting to hate Java applications again. Yeah. So reset this. Reset this. Move it up. There we go. Okay. Dust. Now, beach dust is actually a bit nastier than MDF in my basic understanding. So
yeah, mask it shall be. Do you have a cardboard box that I can put around the top? Not at this moment. G-code is loaded up, machine is zeroed, power is on. Lowest RPM. Same feed rate as before. Same error as before. The tips are actually quite wide, so I'm not burning any wood this time. That is good. RPM are as low as it goes. We can already see the T starting to take shape right there. Yeah, since we can't lower the RPM anymore, I guess we're gonna have to increase the feed rate. This one is cutting beautifully. The end mill is already burnt up. It is actually losing its burnt color slightly. That's from the pass before this one. Look at those steps. The end of the mill already was dark. But the cup looks beautiful. Honestly, the surface finish, look at that. That is near perfect. Oh yeah, it is kind of burnt. This is fantastic. This right here. great! I did mute. Cool. Now it's totally clipping. Let's turn it down all the way. Okay. This is still clipping. This should be much better. Hold on. Huh. Interesting. Okay. Is this clipping? Yes, it is. Shit. I'm just gonna have to talk very quietly. I'm gonna have to talk incredibly quietly for this to work. Okay, well. So... shit. It's probably not any better than before. Okay, so... yeah, I'm actually quite pleased with how this cut is working out, how the surface finish works. Both on the top and on the side surfaces here, yeah, but there's that bit of tear on the top, but like the surface finish on the side and the bottom here, even with that burnt out bit, it looks real nice. I didn't expect it to look that nice on a machine that is essentially built from MDF, from a 10mm thick or 12mm thick MDF frame and a few aluminum profiles. Yeah, it's the mask. Yeah, it has valves and stuff, so it sounds a bit like scuba diving. As you guys are as you guys are pointing out, yeah, upping the acceleration on this machine might help it a lot, especially with that entire burning thing, with getting the feed rates up. That's just going to have to be part of the tuning process that will happen both in the cam, probably mostly in the cam. Just getting the feed rates tuned in, turned up, especially for wood. For aluminum, this is probably fine right now. Give me a second. Yeah, for aluminum, maybe these feed rates will be fine with maybe an 1/8" end mill. This right now is a 4mm effective end mill, so it is still larger than what I would expect this mechanic system to use. But yeah, of course that there will need to be some tuning feed rate wise, and yeah, depth of cut, like it just plunged down there, which made me a bit uncomfortable. Still. So noise-wise, yeah, people were asking about decibel levels. Let me go get the decibel meter. Now this dust isn't really that bad. It's hardwood dust, it's beech dust, so it's not as fine, it doesn't fall apart as easily. And also we're running much lower RPM on the router, so it is the chips are considerably larger, so can't hear you talking at all. You should be able to. So about a meter away we are at 70 decibels with the router turned down all the way. So 70. Yeah, roughly 70. If we turn this up, '87 decibels. Well, if you leave it up all the way and turn on the vacuum, '88 decibels. So quite noisy. Yeah, numbers Part-Time Running is pointing out in chat are correct. Those are the ones that I read. So uncomfortable definitely, but it's not like the loudest thing you've ever heard. The loudest part is the router. Yeah, so the biggest part is just all the resonances you're getting. This spindle is relatively rigidly coupled to the rest of the frame, so all these MDF plates are going to resonate along. So if this wasn't MDF, or if you put some sort of what is it, the black stuff that you're using for dampening in cars, for example, if you put that on this, it might deaden it down a bit. If you put it in an enclosure, in a glass enclosure, or something that didn't sound a bit, that's of course also going to greatly reduce the sound or the noise level. So, okay, we're done.
We're done. Okay. Wow. Why is this so... Oh, I also turned down the rec level. Cool. How was audio quality inside the mask? I was struggling to keep it low enough, to keep the levels low enough, to keep everything from clipping. Hold on, I'm going to turn up the volume here again. There we go. That should be better. Okay. Yeah. Again, so what I was trying to get at is really bad. Okay, I guess better than just noise, maybe, hopefully. So I guess what I was trying to say was that the entire situation here is you still need to tune in accelerations, speeds, cutting depth, all that stuff is still something you need to tune in. I just used the default settings from Kirimoto, which turned out for wood they were really, really slow. For aluminum, maybe they would have worked. I'm not sure how the rigidity of this machine is going to hold up to aluminum, but yeah, really slow. We did burn the bit on the first MDF cut, so it is black on the tip. That is not from the beach we just cut. This part right here, that is from the MDF we just cut at full RPM. So that was not very healthy for the bit. Again, this is just a cheap Chinese bit, so don't worry about it. These are these are probably, I don't know, $1 a piece or something. Not the best bits either, but for this sort of stuff where you're just gonna burn it anyways, like, pff, who cares? It's good enough. So the beach at the low RPM, I was actually seeing chips that were much more along the lines of the chips you do want to see. Let's actually hone in on a perspective right here where you can see the chips we're making. Yeah, right there. So these are the chips that we made from the beach. Those look fantastic. Those look like the exact sort of chips you want to have. If you look over at this puddle right there, can you see that? Oh, that's out of frame. Okay, that puddle right there, that fine dust, that sort of crap, that's what you get from MDF, and that is going to cake up your bit. It's going to cake up your routing channels. It's going to burn everything. It doesn't conduct heat away very well. It's just a mess, especially if you choose an RPM that is way too high. So like I did, so that's obviously not the best thing to do. But again, this beach cut job, I'm impressed by how cleanly this stuff cuts. Like hardwood, it's always a good choice. You can use wrong way. You can use feeds that are much higher than this, and I guess even the RPM you could lower. And the thing with hardwood, it's much more like a metal. It cuts well. It doesn't just grind or rub. It gets you really nice surfaces, even with the bit, even with the there we go. Even with the burnt up and probably already a bit dull bits that we were using. So this is, I'm actually quite happy with it. Of course, the geometry is very soft, very rounded over already in the step file. And with the square end bit that we were using. Of course, it's not going to create a geometry up top here that is going to be particularly smooth. So it is a bit irregular. That is just part of the geometry, which isn't really meant to be cut with a square end mill, but we tried anyways. We kind of succeeded. What you want to look for here is just the surface finish in general. Like the top of this T, this is a perfectly flat surface, and this, I think, you know, the surface quality there is impeccable. That is fantastic. There's no tear outs, no nothing. Even the sides here, this got contoured pretty well. This is a, other than the burn mark back here where it didn't accelerate fast enough. If we can get it to focus, maybe we can move it into focus. There we go. This side surface also fantastic surface finish. So yeah, nice. I am happy. So for wood, let's recap real quick and get to the main perspective. So yeah, let's recap what this is, maybe make it a mini live review impressions thing. So CNC Mill 1, this kit is $3.99. we built it last time. Build took what, 2 hours or something. It's a really simple build, not a lot to it. Uses open builds compatible wheels, not genuine ones, I'm afraid, so a bit lower tolerances there, but cheaper, of course. For $3.99 you get the motors, you get the mechanics, you get the spindles, you get the electronics, which is just a standard Far East CNC board, whatever it's called, 4-axis, up to 4-axis stepper drivers. You get the yeah, all the mechanics, you get the frame, and you get the front panel. If you add up the cost of the components, $3.99 is quite a bit. If you self-source something like this, it will probably be more along the lines of maybe $150 max. But of course, you get the convenience of having everything in one package. You do have to add the router to that. The router is another $100 roughly. There are a few different options. You can get this one without the RPM control, without like any PID tuning or PID loop in it, which is definitely not recommended. You definitely want to have something that has an adjustable RPM, and you could hear it if you turn down the RPM. It goes like and then bounces back. So that is actually regulated at that RPM. So if it goes into material harder and gets more drag on the tool, it's not going to slow down and stall. It's actually going to just pump more power into the spindle and keep the RPM at that low level, which is really important because some tools, if you go at a low RPM and you just barely touch something, it stalls, and then your end mill breaks off, and there goes another $1 or $25, depending on which type of tool, which quality of tool you use. So this Makita, linked in the video description, it's the RT0700C. Definitely recommended. I like Makita. They're good tools. You do need a collet adapter. So in the US, I think they come with a 1/4 inch collet. In Europe, they come with a 6mm collet, roughly the same size, not quite identical. But really, with this sort of mill, you want to use the cheaper 1/8 of an inch end mills that you can get for like usually less than $1 a pop. So I have quite a few of these. These are 10 packs each. You can get them in all sorts of different geometries, and this is really what you want to use with this sort of a mill. So get these things. They're also linked in the video description. The ones from AliExpress, they're actually pretty good. They're pretty good for hobbyists. I wouldn't use them professionally, but yeah, mechanically it is more solid than you'd expect. It cuts wood well. I would actually, without having tried it, I would say it's going to cut aluminum perfectly, as long as you use an aluminum. As long as you use an aluminum that actually cuts well. If you use one that just smears, then obviously you're going to be out of luck. But yeah, get some aluminum that is made for getting milled, and it should be able to handle that just fine. Steel, not sure. Tiny bit. You know, tiny amounts you take off with every pass. Just keep the forces low. Aluminum perfect, steel not so much. Anything that is plastic, probably wouldn't be a problem. Anything that is wood, not going to be an issue either. Of course, we are going to have to see how well the tolerances are going to be with, you know, a machine that isn't perfectly rigid, but sort of rigid enough. In aluminum, I know that my Mendel Max conversion had some serious issues with tolerances in aluminum, just because the deflection was too much. The other thing that I would point out with this is dust collection is just not a part of the kit. And the way that dust falls within this machine, especially with this bottom channel right here, which again already accumulates a lot of dust just from 2 cuts. You're gonna have to vacuum that out every time, or you're just gonna cake up your spindle. Yeah, back here, right back here, already filled up. So dust collection is going to be an issue. You might want to print something, but then again, I don't know how much these NEMA 17 motors with the simple Allegro drivers, the drivers are actually the weak spot, not the motors. These are NEMA 17 motors. They could be even smaller ones and they would still put out the same amount of torque. They're just getting lukewarm. If you use some stronger drivers, preferably Trinamic 2180, the ones on the Duet. DRV don't really get you that much more torque. If you do some stronger drivers, you would probably get a lot of extra value out of that. Maybe even trying some regular Trinamic 2130s or 2100s. Maybe the 2130s with a smart step loss detection. That would be nice. So yeah, that might give you a bit of extra torque. Right now the torque is borderline just enough, just barely enough to cut through stuff. 2130 are the ones with the extra SPI interface, the ones that Prusa uses on the Mark III. Yeah, what else is there to talk about? Yeah, work mounting. Big thing with any CNC. So right now you can see I have a bit of a janky setup. Let's actually take these clamps off. 2660, is that the ones? TP67S109, is that some sort of a larger driver? I don't know about those. So work mounting, not a lot of options. So this is what you get by default. So this plate right here, this is a 1/4 inch, probably Delrin plate. It is reasonably, ow, that's a sharp tool. That's going to be a bit of blood in a second. That is a reasonably rigid Delrin plate with no way to mount something to. So yeah, I guess the way that this is intended to be used is you drill some holes into this plate and then mount something to it. I didn't want to modify this part and cut into it first time I used it, especially since I didn't really have a clue of what I was going to use this for. So you are going to have to figure out some way of mounting your work to this. That might be clamps on the side right there. That might be I don't know, threads that you cut into this plate. Whatever it is, but you are going to have to figure that out yourself. Ow. Yeah. As I said, there is no blood. But yeah, work holding, not too great of a solution yet, especially with what I did with just clamping stuff on. Might need to figure out something permanent. Maybe get a waist plate, get an MDF waist plate like this. Use some countersink metric bolts with that, and just have some threads in this, and then use the countersinks to screw this down, and then use the waist plate to screw other stuff down. MDF is really cheap, and if you mill into it, not a big deal. You just replace it. Yeah, double-sided tape on Delrin, it doesn't always stick that well, so that might not be the best thing to do. All right, aluminum T-slot channels, yeah, but that T-slot channel is going to cost more than the entire rest of the hardware, so not sure about that. What else is there to say? Any other questions on this machine? Personal summary of this thing. Oh, I actually see that the cable is rubbing on the MDF right here and leaving some black rub off. Personal recap. of this experience so far. I think this thing is great. I think it's fantastic. The software still needs a bit of tuning. Kirimoto probably isn't the softest solution I'm going to stick with. I've used Estlcam a bit, ESTLCam a bit, and since the NC files that generates can be read by the Universal G-Code platform sender, I think I'm actually going to stick with Estlcam, which is a €39, I believe, standalone simple CAD tool. A lot simpler than what you get in Fusion 360, for example, but still very powerful, I think. Mostly for 2.5D stuff, but it also does some 3D carving like we just did right here. I like it a lot. I think Fusion is a bit too much for this thing, though you can obviously use it. CPU water cool block. Yes, so project-wise, aluminum is probably going to be the material of choice. Copper is a female dog to mill. Copper is really horrible to mill unless you get the parameters perfectly right, and you're probably you want to use some cooling with that. Cooling in this machine is not going to happen. Let's just put it like that. It's being wood and all. You're not going to use any sort of coolant in this. Maybe like spot cooling manually from a spray can, but you're not going to have flood cooling or anything in here. So copper copper might be very borderline. But yeah, I can definitely see myself milling some very useful stuff with this. Yeah, backplate, GPU backplates, that sort of stuff. Any sort, I think it's having a CNC, having a basic CNC like this. Maybe an X-Carve would be nicer, being a bit larger or something, but I'm not going to judge. Having a basic CNC to augment 3D printing is kind of a good thing, I think. It builds on many of the same principles. You use CAD for both of them. And this is especially, I think, useful with aluminum. I don't really see the point in wood unless it's artistic or something that you do for looks. But if I'm going to mill wood, I might just as well print it from a PETG or an ABS. It's just going to give me almost the same properties, and it's going to be easier to make and less noisy and dusty and all that. But aluminum is really where it's at for me. Copper, again, maybe. And anything that needs the strength of aluminum or the temperature resistance or the temperature conductivity even of aluminum is going to get milled with this thing. I am definitely looking forward to using it more, exploring a few different cam options. Maybe I'll review it. I don't know if I'm going to review it. Who knows? But if you thought like the previous stream that didn't end as planned was kind of a knock on this machine, it's not. Again, that wasn't anything that had to do with the machine. It was just, wrong day, wrong audience in chat. I don't know, but yeah, I've always liked this thing, and I still do. I think it's a great option. Price wise, maybe you'll have to analyze whether that makes sense for you, or whether you want to source stuff yourself and figure stuff out yourself. As it is, nice thing. Not really sure how it compares to those AliExpress special machines that are built from aluminum. Again, this is fairly rigid. Not sure how those hold up. All right. Yeah, PCB milling. Of course, you can do that too. Cutting yet another Prusa i3 clone. It's too small for this. So, yeah. Print GPU backplate. So I guess that's going to be it for today. What else do we have? Let's check the stats on this video. View on watch page. YouTube live streaming has a horrible take on stats. So I wasn't really sure about whether this this stream should stay up on the main channel. I'm not sure. Yet it feels kind of incomplete, but it still feels kind of good to have it. Let me know through that like button. I'm gonna check back in a bit. let's say if we hit 300 likes on this video, I'm going to leave it up on the main channel. If not, I will move it off to the secondary, since it's probably not worth leaving on there. Yeah, so let me know with the thumbs up or down. And what else? Yeah, like it if you like it. Haha. Yeah, links, more info on this machine are in the video description. This t-shirt, again, I just put the shop online if you want to grab this t-shirt, or the one with the frog on it that says, you know, that actually says Ribbit. You can get those on the Spreadshirt shops until November 4th or 5th or something. It's going to have 15% off on anything, so that's nice. So yeah, you can order these. In Europe, it's really cheap shipping-wise, anywhere to Europe, and in the Americas as well, both on spreadshirt.com and .de. Link is in the video description. It's going to take you to the right shop for your region. Yeah, what else? Subscribe, but I guess if you're watching this, you probably already subscribed. That's going to be it. I guess I don't have anything else to talk about today. Thank you for joining in. It has been a pleasure to have you here. Thanks for participating in chat. Again, that's the reason why it's burnt in to the video on the side here. I think it is really important to have that in action. I'm gonna go to bed. Actually, I'm gonna take a shower, get that dust off of me, and I'm gonna clean up here tomorrow. I think I'll have another stream tomorrow on the One How Duplicator. Let's see how that goes, since I already have everything set up. Thanks for being here. Have a great evening, morning, day, whatever it is for you, and see you in the next one.